Okay, and welcome to this final video on kinematics, where we'll be applying the previous video's concepts about Suvat equations to look at Suvat or vertical motion under gravity. Okay, so we'll be using previous videos' formulas and applying it in a different context. Now, when we talk about vertical motion under gravity, we're talking about, in most cases, things being thrown upwards, things being thrown downwards, and in this situation we've got to really be careful with what we declare as positive direction and what we take as negative direction. We've also got to be able to read the question properly. So let's just read through this. When an object is thrown vertically upwards, the speed decreases until it reaches its maximum height. Then it accelerates uniformly downwards under gravity. The acceleration due to gravity is 9.8 meters per second squared, and it's used as minus 9.8 meters per second squared when decelerating. At the highest point, so if we have an object being thrown upwards, okay, that's its motion. Okay, it's gone up, it's reached the maximum height, it's coming down, okay, and it's hit the ground. At the highest point, v is equal to 0. For an instantaneous amount of time, the final velocity of any object at that point is equal to 0. Now, if an object is dropped from the highest point, we assume the initial velocity to be 0 and acceleration to be 9.8. So if we had, let's say, the edge of a building and we had an object being thrown down, the second at which it's thrown, we're going to assume the initial velocity to be 0. Okay. Now we're going to use the same Suvat equations from the previous video, and we've just got to ensure that in these questions we're taking the correct values of acceleration, and we're making sure that we are consistent with our direction. Okay, so in the case of an object being thrown upwards, okay, you have to be consistent with what you take as positive. So if you throw a ball upwards, if you're going to take the upwards direction as positive, that means that any calculation you're going to take acceleration as negative 9.8. Likewise, if you've got something being thrown downwards and you take down to be positive, then acceleration will be plus 9.8. So a ball is dropped from the top of a tower. It takes 5 seconds to hit the ground. Find the height of the tower and the velocity as it strikes the ground. So if I draw the situation as I see it, I've got a tower here, a ball's being dropped, okay, and I'm just going to do a quick bit of Suvat. It takes 5 seconds to hit the ground. That's a time concept, so we've got time. I'm going to take down to be positive, so acceleration is 9.8. We want the velocity as it strikes the ground, so we want the final velocity. We can assume that the initial velocity is 0 as the second it's dropped, and we need the height at which it's dropped, the height of the tower essentially. So let's just think about what we need. We want S. So if I look at my Suvat equations here, do I have U? Do I have T? Yes, I do. Do I have A? Do I have T? Yes, I do. So I could use this to get S. So UT plus half AT squared. U is 0. T is 5 plus half, and then 9.8 and then 5 squared. Okay. And then when you figure that out, you get a calculation 122.5 meters. Okay, which sounds roughly okay in terms of the top of a tower. So that's realistic. We also then need the value of V. So now we've got S. Could we use any formulas for V? So I could use this one as well. V squared equals U squared plus 2AS. So U squared plus 2AS. Okay, so you're going to get U is 0, so V squared is 2AS, 2 times 9.8. times 122.5 takes us over here. V squared is equal to 2,401, and you square root, you get 49 meters per second. Okay, so that is the final velocity at which it hits the ground, which seems appropriate and realistic. Okay, so that's how we apply SUVAT with vertical motion. I'll just recap this. Did a little diagram, you don't have to do that. I did the same technique of looking at SUVAT. I had to take a direction as positive, and by doing so I have a positive 9.8 because this acceleration is acting in the same direction, and then I decided on my formulas. Okay, so that was a situation where we had an object being thrown from the top of a tower. What happens if I've got something being thrown upwards? So I've got a situation here, a ball is thrown vertically upwards with this velocity of 98 meters per second. How long does it take to reach its highest point? So here's the ball, goes up, so it comes down. Okay, so that's its motion. Now all I really want to care about is the time it takes to reach the highest point. Okay, now I'm going to do SUVAT here. Now we know that it was thrown vertically upwards, velocity of 98 meters per second. So the initial velocity was 98. I'm going to take up to be positive. Now if I'm taking up to be positive, then acceleration due to gravity will be negative, minus 9.8. Okay, because acceleration due to gravity always acts downwards. At the highest point, we know that v is equal to 0. Okay, before a split second, flying velocity is equal to 0. And we want time. Okay, we don't really need s. So again, I look at my formulas here, and I think, okay, which one will give me the value of t? Well, what have I got? I've got u, v and a. So u, v and a, maybe I could use this. Okay. If I just rearrange it, I'll get v to be 0, minus 98 over minus 9.8. Okay, so minus 98 divided by minus 9.8, which is 10 seconds. Okay, now a velocity of 98 meters per second is quite a high velocity. So it's being thrown with some force in order to get that. So in order to reach that height, I would say that sounds appropriate, 10 seconds to reach that height. Okay, last question. A stone is thrown vertically upwards with a speed from a height above the ground. The stone hits the ground 4 seconds later. Find the value of height. Okay, so lots of things going on here. So a thrown is thrown vertically upwards with a speed 60 meters per second from a point h meters above the ground. Okay, the stone, so it's been thrown upwards, and that's its direction of motion. Yeah, that's its motion. The stone hits the ground 4 seconds later. We need to find the value of h. So this is different now. If it's been thrown vertically, we've got to take that in consideration. Okay, and for example 3, as I said, the diagram has been done. I've been through the workings here, and I've got an answer of minus 14.4 for my value of s. Now one little correction I want to make with this is that I assumed up to be positive. Okay, and when you do that, the added consequence is that when it hits the ground later, then actually overall it's got a negative displacement. Okay, so from here to there, positive displacement, from there to there, all the way down, we have an overall negative displacement from its relative position when it's been thrown. So I should have had minus s here and here, which obviously gives me an overall value of 14.4 meters for the value of the height above the ground. So that is how we do SUVAT in the vertical motion, and again, it is all about taking direction carefully and using SUVAT, but also using the right formulas as well, and thinking about things in context. Right, that's the end of the video. There are some questions on this page here for you to have go out.